Hey brothers, I'm your lead engineer, and today we're going to jump right into a highly critical explainer. We're talking about the exact, uncompromising procedure for safely removing and installing RO membranes in our ultra-pure water, or UPW, pressure vessels. Look, if you're operating or maintaining a semiconductor plant's pure water system, this is the absolute gold standard you've got to follow. We're dealing with massive pressure and incredibly sensitive filtration here, so precision is, quite literally, everything. So here's the game plan for this explainer. First, we're going to map out the physical RO membrane components. Second, we'll review some of the most common installation mistakes. Third, we'll walk step by step through the actual installation procedure. And finally, we'll wrap up with safety and some absolute key takeaways. Let's get into it. All right, Section 1, RO membrane components. This is all about building that foundation. Now, there is some incredibly specialized engineering packed inside these spiral-wound elements. You absolutely need to know exactly what an ATD and a brine seal do. Inside the element itself, there's a feed spacer that lets water flow across the membrane leaves, which are wrapped right around a central permeate tube, collecting all our clean water. But on the outside, that's where we rely heavily on the ATD, the anti-telescoping device. There's one on each end, and they literally hold the entire element's shape together under massive pressure. Then, at one end, we've got the brine seal. Think of this as a blocking ring. If you don't grasp how this seal prevents raw feed water from just completely bypassing the membrane and shooting straight out the concentrate end, well, your entire installation is going to fail right out of the gate. Picture the cross-section of our pressure vessels for a second. They're usually built from 316L stainless steel with an electropolished surface, though, sometimes you'll see fiberglass reinforced plastic, or FRP. Notice the layout here. We've got a feed inlet on one side, a concentrate outlet on the other, and permeate portholes right dead in the middle of the body. Down inside the bottom of the vessel sits a thrust cone, and when we're loading multiple elements, which is usually 6 or 7 in a series, we use interconnectors. These little guys perfectly couple those central permeate tubes together, so our clean water just flows flawlessly. Moving right along to Section 2, Common Installation Mistakes. Let's talk about the real cost of error here. Okay, so orientation is absolutely crucial. Take a look at this comparison. On the left, we've got a textbook correct installation. The golden rule, that brine seal must face the feed end. This creates a really tight seal against the vessel wall, which literally forces the incoming water to travel exactly where we want it through the membrane leaves. Now, on the right, notice how one tiny mistake with the brine seal orientation completely ruins everything? If it's put in backward, that raw feed water just takes the path of least resistance. It completely bypasses the membrane and goes straight to the concentrate side. And the result? Your filtration efficiency basically falls off a cliff, and your permeate conductivity spikes instantly. Not good. Brothers, I really need you to commit these 10 common mistakes to memory. Number 1 is what we just talked about, the reversed brine seal. It's the most common cause of failure. Next up, watch your materials. Number 2 is missing O-rings or using the wrong material entirely, like swapping EPDM in instead of Viton. EPDM degrades in these harsh chemical environments and causes massive internal leaks. Number 3, using petroleum-based lubricants or silicone. Just don't do it. It causes severe membrane fouling. Number 4 is handling elements with bare, dirty hands. This introduces bacteria right into our UPW system. Number 5 is forgetting the ATD, which makes the membrane leaves violently shoot out of their wrapper, a nasty effect we call telescoping. 6 is loading new elements without flushing the vessel first, letting leftover debris puncture your brand new membranes. 7 is reversing the feed and concentrate ports on the end cap. 8 is uneven bolt torquing. Do that and you'll warp the flange or even crack an FRP vessel. 9 is forgetting to log serial numbers, which completely trashes our warranty traceability. And finally, number 10, and this is literally the most deadly, opening a vessel that hasn't been completely depressurized. All right, on to Section 3, step-by-step installation. Let's get right into the actual procedure. We start with preparation, and step 0 is non-negotiable. You must execute a strict lockout/tagout, or LOTO, on the RO train. Close those inlet, outlet, and bypass valves and bleed the pressure down to absolute 0, and verify it with an independent gauge. Step 1, carefully remove the end cap using your wrench in a star pattern so you don't warp the flange. Step 2 is extraction. Remember, never ever pull an element by its permeate tube. It will snap right off. Always use your dedicated extraction tool to push the element from the feed end toward the concentrate end. Step 3, grab a flashlight, inspect the empty vessel for any scratches or leftover debris, and then thoroughly flush it with UPW until that water runs crystal clear. Moving right into the next phase, step 4 is verification. Double-check those serial numbers against your bill of materials and confirm that brine seal orientation one more time. Step 5, carefully apply a nice, thin,
even film of approved glycerin to the O-rings and brine seal. Let me repeat, never use silicone or petroleum grease. Step 6, gently insert your first element, keep it perfectly horizontal, and push it in with a smooth, twisting motion so you avoid pinching the O-ring. Slide it all the way until it rests snugly against the thrust cone at the far end. Step 7, load up the remaining elements, taking care to properly connect those central tubes using your interconnectors.
Finally, we seal the whole thing up. Step 8, pop your end cap back on, making absolutely sure the O-ring is seated perfectly in its groove and that your feed, concentrate, and permeate ports are perfectly aligned. Step 9, grab your calibrated torque wrench and tighten the bolts in a star pattern, strictly following the manufacturer's torque specs. Seriously, do not over-torque these. Step 10, remove your lodo, crack the vents open, and slowly ramp up the pressure. You've got to run a baseline flush for a good 30 to 60 minutes to wash out all those factory preservatives, making sure to carefully log your initial flow rates, pressure drops, and conductivity.
And that brings us to Section 4, Safety and Key Takeaways. This is all about protecting your life and our multi-million-dollar equipment.
I really cannot stress this enough, brothers. An end cap under pressure is quite literally a deadly projectile. Never stand directly in front of that end cap when you're loosening those bolts. If even a tiny fraction of system pressure is still in there, that massive, heavy steel cap can pop off like an artillery shell. You must always verify absolute zero pressure on an independent gauge before your wrench ever gets close to a bolt. No exceptions. Let's lock in these final operational takeaways. First, the #1 cause of bad salt rejection after a swap is a reversed brine seal. Always check that arrow. Second, your O-ring integrity and proper glycerin lubrication are exactly what stop internal bypass. Third, keep up those strict cleanroom protocols. Gloves on at all times, absolutely no bare hands touching the elements. Fourth, log every single serial number and baseline data point for warranty tracking. And most importantly, you've got to closely monitor your differential pressure, or delta P, for the first 24 to 48 hours. If there's some hidden flaw in your installation, that pressure gauge is exactly what's going to warn you. So I'm going to leave you with this critical, life-saving question. It's one you need to ask yourselves and your teammates every single time you step onto the floor. Is your pressure vessel truly depressurized and completely drained before you open it? Seriously, don't guess, verify it. Treat every single vessel as if it's fully live until you prove otherwise. Thank you so much for your focus today. Stay safe out there, strictly follow the procedures, and let's keep our UPW systems running flawlessly.